Let's get started. So on behalf of the Good System team, welcome and thank you for joining us today. As many of you already know, Good System is a grand challenge at UT Austin. It's 8-year, $10 million grand challenge at UT Austin. We have recruited over 17 different researchers from different disciplines, such as computer science, aerospace engineering, architecture, community regional planning, information, iSchool, history, philosophy, public policy, as you name it, to define, evaluate, and build ethical, human-centered artificial intelligence system together. We're in our second year for our launch. So today we will have an opportunity to learn about the work from our distinguished speakers about the smart city and how that relates to one of our core research project, Go System for Smart City. So this event will be recorded. Just some housekeeping items. This event will last 1 hour. We will have a lecture for 35 to 40 minutes. We'll have a 20 minutes for questions. So if you have questions, you can just type in the chat or use the virtual raise a hand function. I will read out the question to the speakers. So today we are very grateful to have our distinguished speaker, Vonu Thakuriah from Rutgers to give us a talk about urban informatics and the smart city. Vonu is a distinguished professor in Rutgers University and a director of Rutgers Urban and Civic Informatics Lab. Her research interests are in transportation planning and operation, big data, urban informatics, smart city and socio-economic cyber infrastructure, and the social equity and data justice aspect of information technology, AI, and automation. He has a wide range of experience helping government agency and private company find data-intensive and technology-based solutions to complex urban and mobility challenges, particularly strategies that are centered on social justice, which is very related to good system and ethical AI, environmental sustainability, health and well-being, and ethic and responsible innovation in data and technology, also very close to ethical AI. Vonu has published 2 books. One is Transportation Information. Another book is Seeing a City with Big Data, and over 200 journal articles. She has been involved, supported by over $70 million of research from different agencies such as NSF, European Commission, UK Research and Innovation. She also received support from US DOT and other national, international agencies. So without further ado, I will turn our podium to Vonu. Vonu, the floor is yours.
Okay. Yeah, somehow I got muted. Sorry about that. Can you hear me okay now? Okay, good. So thank you very much, Jingfeng, for that kind introduction, and thanks to the Good Systems series for inviting me to speak today. I'm very excited to be here, and I would love to have been there in person, but I'm just happy to be speaking today from New Jersey. So my conversation with you today is going to be about ethics and responsible innovation in data-intensive smart cities and urban mobility management. And as we all know, there's been an explosion of data and information technology products out there, from which we have multiple sources of information at any one time through sensor systems, user-generated content such as social media and websites. We have enormous amounts of data from the private sector, which records pretty much everything that we seem to be doing. They seem to know a lot more about each of us, perhaps even than we realize. Administrative data is a very enormous and interesting source of data. The government, every time you go to, get a new driver's license or to register a new car or pay your taxes, you're generating data that is used by researchers in some cases, but also within governments to process and, in their governance models. And all of these data are now increasingly being connected to each other so that we are having this era with connected infrastructure where you have, transportation systems, smart buildings, smart energy systems, smart water systems, integrated systems, even with massive infrastructure systems such as weather and climate change monitoring, which is put us at a very interesting and good time to sort of pause and ask, are we doing things the right way? Are we doing things ethically? Are we doing things that are socially just? And the era of machine intelligence is especially a time when we should be, I believe, taking this pause to understand the full ramifications of what we are doing. The combination of big data and new learning methods, artificial neural networks, which has been around for a long time now, machine learning as well as deep learning, which really came about in the late 2000s, he's brought about a large number of processes relating to management of data and retrieving information from data that is brought about a period where we have this era of resurgence of artificial intelligence, which itself has had ups and downs over the last several decades. And this is a very exciting time because I think the combination of massive volumes of data on which to train deep learning models, increasing computational capabilities of our computers, and these methods together are pointing us closer and closer to machine intelligence. And some of the short-term applications in these areas are, a lot of applications in the area of transport, which is my field. Autonomous vehicles, people talk about autonomous vehicles all the time because I think it's easy for people, the general population, to grasp what AI is when they think about things like self-driving cars. Other areas are things like energy, precision medicine, fintech, cryptocurrency is certainly very huge. Massive language models, which are able to understand and detect what from unstructured data sources, such as text data. And the whole area of criminal justice is a massive area. And so, every time I listen to ethicists and, people who are talking about artificial intelligence, some of the key areas that I think people, the general public and the media seems to be grasping onto are really autonomous vehicles, as well as autonomous weapons. Now, I know nothing about autonomous weapons, okay? I mean, I don't really know much about drones or anything like that, so I'm not going to talk about it. And I'm not going to talk really also about autonomous vehicles, but I'll talk about other areas of transport which are making leaps and bounds, moving ahead with artificial intelligence, deep learning techniques, and not so much on the technology side of it, but really as the subject of my talk, on the ethical implications and the responsible innovation implications of that. Now, beyond the short-term applications, AI experts also talk about long-term AI, which is general artificial intelligence, machine intelligence, which has general cognitive abilities, which is probably far away in the future, but at the rate at which we are moving, it may not be that far away. Although I suppose different people will have different ideas about how close or how far away we are to general machine or artificial intelligence. So ethics and responsible innovation. Okay, so ethical AI really goes beyond what is what we should do and not do, to ideas that come from morality, moral principles and techniques that are intended to inform development and responsible use of AI technology. And while there are many dimensions to the discussions on ethics. Some of the major issues that have people are focusing on are relating to privacy, algorithmic bias, and non-manipulation, including things like fake news and so on and so forth. A related concept is responsible innovation, which really hangs on the idea, addresses the issue of how do we govern innovation in a responsible way. And again, there are many frameworks for responsible innovation. Responsible innovation is taking care of the future through collective stewardship of science and innovation in the present. And that is one definition that was given by someone. And in this case, this approach is based on anticipation of what will be in the future, even though you're working and innovating in the present. Reflexivity, inclusion, and responsiveness. And the objective of my talk today is to raise questions and discuss trends regarding ethics and responsible innovation in the context specifically on smart cities and smart mobility, and not in general terms. These are the areas I know most, and discuss some ideas about what needs to happen going forward. So cities and regions in the 21st century, as we all know, are concentrations of innovation and economic growth, but also facing extreme challenges of both a human and a social kind in now after COVID, from the perspective of public health, enormous environmental and physical challenges relating to extreme weather, climate change, and other things like that, as well as economic challenges arising from volatility in our economic systems, potential recessions, inflation, adding significant complexities to urban governance. Now, within this context, cities as a concept has been an area which has seen a significant investment of smart infrastructure. In fact, I like to think about smart cities as having 3 different versions, and there'll be probably more versions in the future. The first version is talking about investing in smart infrastructure, smart ICT infrastructure, and the focus really was on effective resource management, cost reduction, and accountability and performance monitoring. The second era, if you will, or epoch, talked about smart innovation. So now that we have this smart ICT infrastructure, how can you create innovations out of it, business-led development, improvements in civic leadership out of knowledge discovery and insights gained from the data infrastructure. And the third version, which is something I like to call smart citizenry, which is really the idea of future cities, not smart cities. The idea that, you have a basic data infrastructure, you have ICT infrastructure, you have broadband, you have ways about connectivity between the data sources. How can we have well-informed and engaged citizens? How can we talk about, service delivery and social innovation, social learning, social capital, citizen choices, and well-being? So smart cities in general has the very technical oriented smart cities have had a lot of criticisms, I would say, because smart cities by themselves in its technical manifestation does not necessarily lead to good outcomes. I do believe that you need a smart citizenry as well, and that is where the concept of future city comes in. So in transportation in particular, we are seeing really a wave of innovations: autonomous, connected, cooperative, anticipatory, shared, Uberification, personalized in terms of micromobility, and very much integrated with other services such as smart buildings and smart energy systems. And in trying to understand how transportation demand may change with this kind of technology, or as society changes or the economy grows, or contracts, there are many different, this is not new. I mean, there have been generations of models of transportation demand. Some are analytical models based on theoretical relationships between different concepts that determine what the outcome would be in terms of transportation demand. There are massive theory-based models drawing from different disciplines such as economics, operations research, econometrics, and so on and so forth, that talks about how demand and supply play against each other and ultimately leads to transportation as a derived demand. And the little picture on here on the left bottom is really the first generation of real-time models, I would say. This is something that I worked in together with a private company, the idea about how you use real-time speed data as well as data from weather forecasting, massive weather forecasting systems in order to create real-time route guidance for in-vehicle navigation systems. And in there, we use kind of what I call a first generation kind of machine learning model, support vector machines. And they were very powerful and gave you pretty accurate results. So I'm going to quote Alan Wilson, a very well-known geographer from UCL, University College London, in 1984. He said that there are 3 disciplines most directly concerned with the theoretical basis of urban modeling, and they are geography, economics, and sociology. And those that are concerned with urban problems and their solution, and those are town planning and transport planning, the latter most often a subset of civil engineering. So against that backdrop, I'm going to give you just a little insight into something I recently worked on with some collaborators, short-term demand. In the next 5 to 15 minutes, how can you predict demand for Uber services, for example? And we use data from New York City. And the idea is to predict pickups by temporal and real-time features, time of day, day of week, and hourly weather conditions, demographic and social demographic features, travel to work, and all of that. And the interesting part about this model is that it is really a multivariate architecture compared to many time series type models. And we used a deep learning model that is based on WaveNet technology, which is a convolutional neural network originally used in the prediction of sound waves. And it's a very complex model. I'm not going to go into the details. I just wanted to tell you that these models are enormously powerful. So this is a model that took a gigantic amount of time for us to work on. It has many, many different parts and pieces to it, different embedding and inputs, convolutional layers, residual blocks, activation functions, and so on and so forth. It makes it a very complex model. And in this table that I'm drawing out for you on the slide, it compares UberNet, that's the model, the WaveNet-based model, to something like Arimax, which is a multivariate form of ARIMA time series model. And what this root mean square error or the average prediction error of 177 is saying is that the average prediction for 15-minute interval is about 177 with the UberNet model compared to the Arimax model, which is 207. And if you, over the course of a day, this can hypothetically translate to over about 3,000 correct predictions by UberNet compared to Arimax. And if the average New York City UberX ride is about $30, which it was in 2015, this would translate to potential revenue of about $93,000 per day when compared to Arimax if demand were to remain constant. And this kind of results, when you see it in that context, is very powerful because obviously, it is important for ride-hailing companies to understand how to accurately do surge pricing, for example, or to allocate vehicles to different areas, for instance, to reduce idling, so the drivers can reduce idling and lose revenue in the process. It's also good to have accurate predictions for third-party operators that can provide better location-based services. And most of all, you as the passenger who's waiting for Uber or Uber ride, you have lesser uncertainty waiting for the ride to show up. So these models take a lot of enormous amounts of time, but compared to the state-of-the-art machine learning or time series kind of models can do very well. And we are seeing more and more of these kind of systems working in the city space. This particular picture is about language-based detection system, continuous monitoring of in real time using social media data. And how do you use language patterns from social media data, newspapers or whatever, news breakout news to understand the underlying users, activities, and concerns of cities. And again, this is a hugely complex endeavor. I mean, in this particular application that I'm showing you, and this is not like a standard approach, natural language processing is very important. I mean, many of us have heard right now about sentiment analysis and all of that, and those are very important ways of learning about different parts of the city. But I think the innovation in this kind of work was about better location prediction, because when you think about it, only about 0.8% of the worldwide Twitter firehose is geotagged. So there's a lot of information that we don't know where it's coming from. And this application really has an enhanced geolocalization procedure that allows us to gain location information from a large swathes of non-geotagged tweets. And in the end, you get interesting results because you get to know more about what is happening in the city in different ways. For example, which areas of the city are more hazardous in terms of crime and traffic crashes? It is actually very difficult to truly say that. I mean, many of us have, analyzed police records or hospital records or even traffic crash records and so on and so forth. At least in the city of Chicago, where I used to live before, there is a tremendous amount of non-response bias in all the sources of data, standard administrative data, as well as significant levels of, survey data tends to have non-response bias. And, using our social media geolocalization enhancement technology, we were able to find that whereas if you analyze government police records and administrative crash records, there are only small areas of the city which show up to be truly hazardous. But if you look at the results that we get out of our Twitter enhanced geolocalized data, we find that there are many other pockets of areas in the city where people find, have dissonance, or they feel they're in some sort of hazard or in danger. So this is a good approach to find out what the fabric of the city really looks like in terms of where it is safe, where it is unsafe. And it's a good approach because although, again, I mean, because this is unstructured data, so much is not known about the quality of it. But at the same time, some of the gold standard survey or administrative data sources also have missingness that are not totally at random. Imputation is difficult, and they arise from the usual sort, non-response arises from the usual sources, as well as things like language barriers, mistrust of police and other authorities. So the benefits of such a system is that you discover underreporting, so you have a better or more complete understanding of discontent and risks and hazard spaces in the city, and identification of where there are stressors, and also helps you understand or identify disparities in exposure to traffic crashes or crime and so on. But at the same time, they also have tremendous potential risks. One of them includes, potential for misuse through surveillance and crime prevention analytics that has been known now to widely and disproportionately affect certain communities, minority communities of color, low-income communities. Re-identification of individual persons without consent and privacy lost if not used in an ethical way, and scoring of certain areas as less desirable, which may be used in punitive ways by less ethical, let's say, employers or mortgage companies or credit card companies, which is trying to determine your creditworthiness. Here is another example of computer vision-based system. This is an experiment that I was involved with, where we had instrumented citizens of a city with a life logging device, in addition to an extensive survey that they had to fill out. And this life logging device collects through GPS your location data or movement data. There's also accelerometer, magnetometer, light sensors, and temperature orientation and all of this stuff. And so One of the uses for this kind of data is that it allows us to understand social distancing in privacy-preserving manner under normal non-pandemic circumstances. So, for example, there are now a lot of papers where where you can see that people have used cell phone data and other sources of data to measure social distancing or physical distancing. But that's during COVID times. We really don't have an idea about how much of our daily lives we spend socially distanced or physically distanced from other sources. And so we have this analysis where we were able to use machine vision algorithms to identify, in the images, how many people are there, what the distance and depths are between people, and whether they are not, they're interacting or not. And not only that, we are able also to identify, let's say, occupational industry settings where people have jobs where they're more isolated versus where they're not isolated. And again, this kind of, machine vision algorithms take a lot of work, but fortunately, there's already a number of pre-trained models and so on by means of which we are able to expedite our workflow. Anonymization, as you can imagine, is a huge issue with this kind of image data. And we have done a fair amount of work in this area to de-identify image data. And, when you think about de-identification of image data, the first thing that probably comes to mind is Google Street View, where they, sort of blur out the license plates. But this is the kind of data that is really, truly difficult. I'm going to skip the slide. There's significant technical challenges associated with the data because the data are extremely dirty and noisy. They are, as somebody's moving around, as they're wearing the live logging device, there might be a lot of jostling and movements. So the data from one image to the other, this collects data every 7 seconds. It could be very, very unrecognizable. A lot of data may not be usable. But so there are those kind of technical challenges. So it's not straightforward machine vision algorithm usage. Anonymization from face blurring, but what about unique re-identification? Even if you blur someone's face, you might be able to uniquely re-identify someone. So for example, people tell me that my English Cocker Spaniel has very unique markings. So in an image, even if my face is blurred, somebody might be able to tell, aha, this must be Vonu because a dog, we didn't blur the dog, right? So, I mean, those are the kind of questions that you really need to ask. And then who's informed consent? So usually in the survey world, we are used to taking informed consent from the subject or the respondent. But if you have people's images in your pictures, whose consent are we talking about? Should we be taking informed consent from friends and co-workers or anybody else who are to appear in your image? Then we also found out that technical literacy is an issue. Device wearing is a big challenge for some people, and the sample itself may overrepresent technologically savvy individuals. And there might be other kinds of issues such as time of day bias. These are automatic cameras. They come alive, they get activated if the light meter says the lighting is okay or above a certain level, better than a certain level. So you may have less visibility or rather less data during circumstances when it's a little bit darker or things are not well visible. So having seen those examples, let's look at ethics and responsible innovation in this kind of context. And my full disclaimer is that this is really a 36,000 feet version, and it is really primarily based on my own research experience. So I already read out what this, at the beginning of my talk, what I mean by ethics and responsible innovation. And there's also one thing I wanted to point out is that ethics is not limited to what is permissible by law. Legal limits set a minimum threshold to responsibility and acceptability, while ethical AI sets policies that go beyond legal to moral obligations and respect for fundamental human values. So although ethics and law work close together, they're really not the same. And of course, the whole issue of the whole area of responsible innovation is trying to understand what are the governance methods by means of which we best address this kind of dilemmas. So breaking it down, I believe when we're talking about ethics and responsible innovation, these are some of the big ticket areas. Cyber infrastructure, again, an area I know nothing about, so I'm not going to talk about it, but I think you can imagine that cyber infrastructure really has to do with security from cyber security, really has to do for security from things like ethical issues such as cyber ethics and hacking and so on. Privacy, fairness by design, data democracy, data justice, AI impact, and longer term issues are some of the key issues that are relevant in this area of smart cities, smart urban mobility, and AI. So privacy is really the right to be left alone. It's viewed as an inalienable right, but at the same time, it's kind of confusing sometimes for many, the right to be physically left alone versus the right to have one's information be left alone, or personally identifiable information be left alone, are can be confusing. Now, studies of privacy, including some done by us, show that privacy is not a static, immutable constant for most people. There is an issue of people do trade off utility or private. People do trade off privacy for utility or minimization of risk, or for some sort of other compensations and trade-offs. So that it's another aspect that makes it very difficult. And in an earlier paper, we had said that the major ways to approach privacy in this domain, in these areas, are privacy by design, where technological approaches might be taken in order to protect your privacy, such as differential privacy is the approach that's used by US Census, synthetic data, things such as in the location world, in the moving objects world, you have all kinds of other approaches such as cloaking, pseudonyms, etc. Regulations is another big approach. Of course, law and legal aspect of privacy is very, very, up and front and center. And the strongest legal approaches I know of are really the General Data Protection Regulation and the recently passed Data Services Act from the European Union. In the US, we have the HIPAA principles. You probably know about that. You have to sign a form when you go to a doctor. And there's a variety of fair privacy principles that have been put out by organizations such as FTC. But in general, there is not a comprehensive federal approach to privacy in the United States. There are many legal, local as well as sector-specific approaches. And the final approach that my co-author and I wrote about is that it's not enough just to have technology-based privacy approaches. It's not enough to have regulations. There has to be greater awareness by consumers and their education. And this is, people have to know that, you can't want privacy and have your entire party photographs on Facebook. I mean, that's not going to work. And so this has admittedly been a slow area. And so I do believe regional data centers and so on and so forth can play a role. Privacy by design, fairness by design. Now, this whole area of explainable AI is getting a lot of attention. The black box nature of deep learning and machine learning has triggered a lot of concerns about, what do they mean? What comes out at the other end? How do you interpret all this? And generally, there's been no consensus on a general definition of explainable AI. But some of the pillars, I tend to agree with this, this approach given by the National Institute of Standards and Technology. It has to be explainable. I mean, when output comes out, it has to come with accompanying evidence or reason. It has to be meaningful. It has to be understandable to individual users. It has to be accurate, and it has to be operating within limits of knowledge, that the system only operates within conditions for which it was designed. And when the system reaches, or when the system reaches a sufficient confidence in its outputs. Now, other elements of satisfactory explainable AI include causal definitions, having counterfactuals, having symbolically grounded approaches by means of things such as ontologies. But I think this NIST approach is pretty far-reaching. Of course, the devil is in the details. How do you make this operational? Some of the biggest areas of fairness by design that has received attention are things like algorithmic bias, which we have all read about in many ways in newspapers at this point. And bias may occur due to many, many different ways. It could be due to inadequate sampling. It could be because somebody annotated the training data in a machine learning model incorrectly or left out something, or it's incomplete. It could be, it could be anchoring bias due to over-reliance on the first piece of data that came along. And currently, as I said already, in the United States, there's a whole lot of activity going on in primarily state and local legal landscape about algorithmic bias. So for example, I just found out fairly recently that starting in January 1st, 2023, New York City Council now has a regulation that says that employers who use automated employment decision tools that use things like machine learning and AI and so on and so forth, to hire people will have to, go through independent audit or pay fines. There are a couple of bills in New Jersey that I saw, although I haven't tracked down what happened to them recently. One has to do with, I think, housing mortgages, and the other one has to do with credit worthiness. So there are all these other issues that are out there, but one of the key other aspects that has really been emphasized recently, again, by the Data Services Act is actually this transparent terms and conditions for platform users. Now, in an earlier study, we found out by doing text mining of location-based services privacy policies, we found out that the reading level based on the Kincaid-Flesch reading score of this location-based service privacy policies like Google Maps and so on and so forth is roughly that of a sophomore to a junior in college, which is well above the reading skills of the average US adult. So that itself is something that needs to become much more transparent and accessible. Data democracy, this whole issue of who has access to the data is another aspect of ethics. Data is the new oil. Yes, I agree with that. I mean, the data is power. If you, the way we see big tech or government organizations working, and there's been this open data movement, which is really focused on openly available data sets, open source code, et cetera, et cetera. And in fact, the new Data Services Act of EU is requiring access for researchers to key data of the largest technology platforms and search engines in order to better understand online risk. But really, data democracy, a part of it is going to be all these things like having ontologies or data interoperability or standards, metadata, resource discovery tools in order to have better access to data about ourselves and our communities. Data justice, again, this is an area that is very near and dear to my heart. Marginalized groups, low-income groups of households from, communities of color are more likely to get left out of data sets. In fact, I think the census, 2020 census has undercounted persons of color and had done that as well in the past. Missing or incorrect data and opaque models can do harm. And we see this particularly in areas such as environmental justice, policing, health services, social services, and all of that. Now, one of the things that has happened is that way back in, the early, the mid 2005, 2006, let's go back to there, the traditional users of urban data were, regional planning organizations, operational agencies such as Department of Transportation or Department of Energy, et cetera, and research organizations and universities and consulting firms. In this paper, we did some analysis of who the data entrepreneurs in smart cities are, and we found out that in contrast to traditional urban data users, we now have a much bigger landscape of users of urban data, ranging from big, huge, multiple information communication technology companies to specific smart cities companies, as well as civic hacking organizations, community-based information service organizations, and so on and so forth. and the independent app developer, the Civic hacker, the one person who's very passionate about their living conditions and their communities and cities, and they're sitting there coding in the middle of the night, because they're very passionate about it. Now, the 2020s ecosystem has changed slightly since then, I do believe, and this is a little Google Trends I did minutes before this talk. This whole issue of data for public good. Now, people earlier talked about running the city efficiently and smoothly, and now more and more people are talking about how do we leverage the data so that it benefits society, benefits low-income communities or communities of color, and all these organizations have now come up, and they're really very active in the data landscape, such as data for social good organizations, data for racial justice organizations, social movement activist organizations, street protest and activists group, crisis management organization, and civic AI, as well as ethical AI groups. And they're collecting all this kind of interesting data. This particular one is using cell phone data to find out which communities faced disparities in access to food in the beginning of the pandemic. And we found that, there are certain communities that were unable to access goods because they had, low car ownership, as well as reduced public transportation services because of the pandemic. And because of that, they had to go expose themselves to COVID more frequently by visiting, by making more frequent shopping trips, which was not something that we saw in high income areas, because obviously they didn't have, a car to pile, buy a lot of goods at the same time. So these are the kind of trends you see. And overall, I think this COVID has really highlighted, it was really a data-driven approach to understanding the huge disparities in the health landscape in the United States. And so that has led to a data-driven social activism. And we are doing some work in this area. This is very early work. This is not complete. I'm just putting it out there for now. The idea of, looking at where Black Lives Matter protests occurred and their effects on urban assets and operations compared to other protests, let's say, such as, Occupy a movement or All Lives Matter, and, for example, what were the impacts on transportation or subway ridership? And this is a study that's underway. And so I just want to quickly say that, as I wind up, that the impacts of machine learning is the most important question we should be asking is, why are we doing all this? I mean, what new knowledge or ways of operating and transportation systems or smart cities are being generated as a result of learning all this, of utilizing all this data and utilizing all these insight-bearing technologies? And also it helps us answer, I think, unintended consequences. Where are things happening, or what are the impacts that we had not foreseen? One example is crypto mining and energy impacts, or another example is gig economy, the rise in part-time jobs as a result of the sharing economy. This whole issue of Jevons paradox, as access to resources become easier, are we going to demand more of it? So there are more congestion effects. So that is something else we should be asking as we design this kind of system. And of course, the most important aspect of, in terms of the far out implications of, the unintended consequences regarding some of these AI systems in the future. So, there are certain things that that will happen in the future that are known and anticipated, some that are unknown and unanticipated, and there are things that we have absolutely no idea about, such as, probably, hostile AI systems in the future, perhaps mobile malevolent systems, loss of control. And as we move towards general AI, a lot of principles and work needs to be put together around AI governance, such as the Asimov principles and IEEE ethics of autonomous and intelligent systems, in order to be able to more accurately deal with the unpredictability, which may have great severity of consequences. So in summary, smart cities and technology have much promise, but much remains to be done to build impactful, inclusive, and ethical applications. And these are, this is a new, I just wanted to end up by saying, we have started a new master's degree in this type of areas. You might be interested in knowing more about it. Feel free to reach out to me. And I would like to thank you very much for listening to me. And these are my collaborators. This is a short abbreviated list. There have been others as well. Thank you.
Thank you, Vonu, for the wonderful talk. It's very comprehensive and very deep as well. Give us a lot of useful information about the smart city, urban informatics, ethical AI, you name it. So I'm sure we have some questions from audience. I will open the floor to the audience. Audience, if you have a question, yes, can raise a hand and write in the chat. I see Aya already raised her hand. So Aya, please go ahead.
Yes, so thank you so much for the great presentation. So I was wondering, so whenever we are thinking about the smart cities, there are a bunch of implicit biases in our historical data.
Aya, can you please introduce yourself?
Oh, yes, my name is Arya Farahi, and I'm an assistant professor in the Statistics and Data Science Department. I'm one of the co-director of Urban Information Lab. So, so when we are thinking about the smart cities and the data, there are a lot of implicit biases in our historical data. Subset of the population are underrepresented and underserved, and another subset of the population are overserved. So do you have some suggestion how we can incorporate different sources of data to identify different subset of population and how to quantify which subset of the population is overrepresented or overserved over the past like a few decades, and basically how to correct for this type of historical biases that we are seeing in our data?
Yes. In the example I had showed you about Chicago, for city of Chicago, for example, I'd known for a long time that there are certain areas that, you know, it's very hard to get high response rates for things like surveys and so on and so forth. And not only that, if there are if there are crashes, if there are minor crashes, or if there are minor crime that has happened, there is less reporting to police and so on and so forth. So that was the reason why we undertook this enormous study using social media data, and probably it might have been one of the first of its kind because it was done in the early 2010s. And we found that, yes, there are potentially pockets of high-risk areas, which we were able to determine from social media data that were not showing up in surveys and in police records and so on and so forth. But that was for a very specific context. I think the way I look at this is that my response to it was to inform the city government that, look, this is what is happening. There are areas, there are immigrant pockets in the suburbs that, you didn't even know that they were there because of the dissonance or the disconnect between some communities as well as and government agencies. So I think we have to bring a lot of people together and not see it only as a data project, but really as a project of fundamental inequalities in governance. And that's the way I looked at it. There are areas where, if a kid is, is been hit by a car, but really nothing much happened, there is not a police report on it. But if you really look at anecdotal records, or we looked at Spanish language newspapers, for example, we looked at Dominican churches, to understand the true scale of the underreporting, and it is vast. And I can tell you one thing, those kind of underreporting have real world consequences. So for example, I do believe that a level 1 trauma center was closed down in one of those areas because the official crash records did not show that was a hazardous area, for instance. Level 1 trauma is where they will actually do, brain surgery, if you will. If you meet in a serious traffic crash, for that you need very special equipment in your hospital emergency room. So, those are life and death decisions. So it is a real issue, and I think that should be one of the front and center issues associated with smart cities. I hope that answers your question, but my question is it's not a data question alone, it's a governance question.
I see Aya has a sum up. Also agree with you, Vonu, that's a social question rather than a data question. Well said. Any other question from the audience? To fill the time up, I do have a question.
There is somebody here, Kijim, I think.
Kijim?
Yeah, hi.
Hi.
Thank you for Dr. Thank you for the presentation. It was a wonderful presentation, and I really learned a lot. My name is Kijin Song, and I'm a postdoc researcher in the Urban Information Lab, and I'm working with Dr. Zhao. I have a question regarding the some data justice. So from the data justice perspective, how can the new type of data can help the better represent some hidden impact on some underrepresented populations, like public health or some social impacts? Do you have any thoughts on that?
Yes,
especially compared to the census.
And maybe the answer I can give you is, I'll certainly come back to the question of health because that's very important. But if I may tell you a little bit about this study we are trying to do, that I showed you some initial pictures of. A lot of the times when there are street protests, for example, or a rally or a procession in support of some social justice issue or racial justice issue, many times the only record you have of it is actually the police records. And that's an enormously valuable piece of data. So whether it is traffic police who is guiding the procession or the crowd, or it's actual if the protest becomes violent, an actual police intervention, that's not the only data you should have about something that is a passionate expression of someone's wishes and aspirations, which is what a social justice or a racial justice kind of street protest is about. So lately, there are some organizations that have taken on the job of having descriptors or creating data sets of social justice or civil unrest events all over the world, including in the United States, and they're very powerful data sources. Some of them actually count how big these crowds are, what happened there, was it a violent attack, or was there any violence in there, or was it a peaceful demonstration? So I think that kind of data, this kind of what I listed under the social justice category, that kind of data is new. And also it's very important because now it gives you there's a higher chance of having a more balanced view of that social movement rather than only looking at police records. So that's one point. The second point you asked about is on health and how social justice data can afford health. I would say that the whole area of social determinants of health is about that. Many health outcomes result because of stress and violence and bad living conditions and all of that. And we don't really have data on those upstream determinants of health. Or if we do have them, and we do have them in some circumstances, they're elsewhere. They're not linked together to the health data. A lot of what is happening right now in the health justice groups is actually linking together health outcome data, like who has diabetes or who's, a stroke or whatnot, and to upstream determinants of health. Where is it most stressful to take public transportation, or where are employment conditions poor and likely to lead to hazardous health impacts? So I think that is a very big role some of these health justice people are trying to play by linking together those upstream determinants of health data to actual health outcome data. Does that explain your, is that the right, is that an appropriate answer to your question?
Yes, absolutely. Yeah,
Okay.
Thank you so much.
Thank you. Is there anybody else I can clarify something or? Sure.
When I wanted to have a question for you. So
Yes.
you mentioned that data become many players are involved in smart city and urban informatics. So what is your view about our role as an academic? Also, what's your view about this, like I would say, this field of industry? Because there's a lot of big players coming to this field and come and go. So I guess that's just one question. So I want to hear from you.
I think there are a lot of scientific questions open in the area of smart cities, or in things like transportation or urban design and energy, technical questions. So from an academic point of view, those questions are right questions to explore using methods and data. But as I said, I mean, my feeling is that from what I hear is that smart cities is a concept that has been around now for a while. And it's seen as a very technocratic approach to addressing city challenges. And there's a greater realization is that it's not just about technology and data, and that you need to get the citizens in the loop. And how do you do that? I think that's where we are right now. And I think that is a step in which we can play an important role, because it's not clear how we can get citizens in the loop.
I agree. I think that's well said. Totally agree. Get more public involved and in the loop. So do we have any questions from the audience? Going once, going twice, going third time? All right.
Thank you. Thank you very much.
Thank you so much. Let's give one applause. Big applause.
Bye-bye.